Hello and welcome back. So that short break turned out to be a very long break that included a long nap. So I guess we're going to continue using looking at the Unity physics examples. Yeah. So last time we looked at triggers, but then I found out there's more triggers. But before we do that, we're going to look at contacts. And I took a peek at this and it looked pretty much the same as triggers, but it's using collisions instead. So we'll take a look at what happens. Oh yeah, so I was watching the recording that I made yesterday, and I saw that my Oculus Quest window on the bottom left was blocking a lot. So I made it transparent, which will help you see behind the window, I guess. See all these files that you couldn't see before. So pretty much what this is doing is pushing the sphere up. This box is pushing the sphere up. So you can actually be doing that using restitution, but I think it does some collision event. So we're going to look at the repulsor cube, and as I expected, there was a script. So this script does iConvert, I'm pretty sure. Yep, iConvert game object to entity, and it adds collision event impulse. So it adds this component when it converts it. So like the trigger, it has a physics world system variable and the impulse group. Well, it has an entity query with the group that we want to check against. I think that's what it's for. It actually isn't even used, surprisingly. I don't think this one was used either. So this query isn't actually used at all. But it's pretty much another way to make an array of all the entities that have a certain component or components. This is more efficient than finding every entity that has a certain component / components. The only issue with this is that if you add a new entity, this won't be accurate anymore. I assume. I'm not sure how entity query works just yet. Anyway, same as trigger event, there's a collision event instead. And it's checking if something is dynamic. It actually isn't checking the entity physics body if it's dynamic or not. It's checking if it has a physics velocity, which is kind of the same thing. Now this one's more accurate. Is body a repulsor? So is it part of the impulse group pretty much? That makes more sense. Unlike this one before I changed it, it said is it a trigger or not when it wasn't checking for a trigger. Anyway, looks the same as before. The only difference is that it's a collision event rather than a trigger event, so I don't know if it'll pop up here also on trigger. No, it's not on behavior. If we go here, on trigger, so the same as on trigger, well, same as on collision in this case. So same as on collision enter, but instead it's for all the components, I guess. I don't know what I'm talking about. But basically, if there's a collision, this will be called. Yeah. And the logic is pretty much the same as the trigger, except collisions just have a collision box. Now this code specifically, so it checks if body A is a repulsor and body B is dynamic. It gets the impulse group component, the impulse component, collision event impulse component for entity A, and it gets the velocity component, the physics velocity component of entity B. And it sets the linear velocity of the physics velocity of entity A to the impulse component, the impulse of the impulse component. So this impulse. So we might be able to see it here. So it's a repulse sphere. Okay, so it does it direction 1, which is up, and times it by 10. So if we look at the sphere when it collides, we can see that the linear velocity turns to 10 once it hits it. Yeah. Now we set this to 0. It should just stay up in the air. Or will it just keep on going? It'll probably just keep on going up forever. Yeah. Because there's no gravity pushing it down. So they collide and the sphere gets 10 linear velocity on the y-axis. Simple. I hope it's simple to understand. Alright, now time to look at the triggers. These other triggers, which I've never seen before. The rest I have somewhat seen before, but this It's completely new. Oh, cool. It changes the material. Now, how does this logic work? So these spheres are just physics shapes in the physics body, so they don't do anything special. And these static cubes, same thing, just static, not dynamic. Now here's probably where the magic happens. These trigger layers, and they are convert and destroy. Right, so let's look at this trigger volume behavior. Now I have no idea what flags is. I've never used this before. And I don't know what this means. Double arrow 1, 1 double arrow 0. I have no idea. And here's the component that I assume is going to be added to the entity. No, it's not. Oh, this is a bit more complicated. Alright, so are flags like multiple things you can select? I feel like that's going to break everything, so I won't do that. Public test flags. Because a normal enum you can only select one, but I'm assuming with flags you can select multiple. Now if I put the flag onto here, I should be able to select multiple? No, I can't. That's not how flags work, I guess. Oh wait, it's not multiple choice. It's not. Never mind, I was looking at it wrong. I don't know. I completely don't know what flags are. At least this flag thing. I guess I'll search it up real quickly. Okay, so I kind of get how it works. It's just something to check against, but you can put multiple values. I don't get the bitwise operators though. Moving on, we're just gonna skip it, I guess. So we add a trigger volume to the entity. So it has a type and current frame. Type is whatever type we set in the inspector. Current frame is 0. Oh, this is something different. And simulation entity command buffer system. So as usual, it's getting the build physics world and the step physics. Pretty much these two systems you'll see in every trigger and collision system, job component system. Oh, there's a lot of jobs right here in the one class. Oh yeah, it's after end frame physics system. So this job just increases the current frame. So every entity that has a trigger volume, the current frame will be increased by 1. So I have no idea what this is. P counter. I have to look at the update, on update. And that's a lot of job handles. I guess we'll look at the on update first. Oh, so I see what this array is for. So the way to get data from a job is to use a native array, and pretty much you don't dispose that native array, it's in memory, and you just access that place in memory, because you can't directly reference it, if that sentence makes sense. Pretty much, native arrays are required to extract data from a job. The thing I don't understand is that, why does it always turn it to 0 at the end? Oh, okay. It's using it here, and then it's setting it back to 0. So mTrigger entities index is pretty much more like a counter than an index. Pretty much it counts how many entities. It's just a counter for various jobs actually. So with get trigger event count job handle, it's just counting. It's just adding 1 for every trigger that has happened. Alright, so this one counts and then puts it into trigger entities. So the size of trigger entities is the size of what was counted, and it's shoved in here. So to make this easier, I'm just going to split it so we can see the job itself and where it's being called. So this list trigger event entities, so here. So it's getting the physics velocity group array as read only, and the volume group, which is trigger volume array. So trigger volume was this component. Trigger volume was the component that was added for every entity that this is attached to. No, every game object this script was attached to creates an entity which has a trigger volume with the type that was set in the inspector. So pretty much all these have a trigger volume. So all these will be accessed. No, it's accessing the array with all these objects. All of these objects. Or anything that has a trigger volume. And trigger entities is passing in this array. And pcounter is passing in the entity array, the entity index, which was used to count beforehand, before this job. And it was set to 0 before doing this job. So here's the trigger event that we talked about last time, where whenever a trigger event is called, there's entity A and B and other data, and it checks if it has a volume, trigger volume, checks if entity A has a trigger volume and entity B if it has a trigger volume. So this is incorrect. Well, the naming is confusing. It's not checking if it's trigger, it's checking if it has a volume group. No, it's checking if it has a trigger volume component. And if they're both trigger volumes, it'll just return and just go to the next job, the next entity. And it checks if it's a physics velocity, which is pretty much a dynamic object. And pretty much if one of them has a trigger volume, but the other one doesn't have a physics velocity, then it'll just return and cancel that loop, I guess, and go to the next entity in this job. So pretty much this is just adding one to the p counter, which was the m trigger entities index, which was 0. So this will be 1. It'll be 1 and then -1, it'll be 0 on the first loop. I'm guessing the next time it executes, the next entity will be 1, I guess. Now the count from before was put into trigger entities, and now it's making a new trigger entities array? No, it's making another trigger entity component. So pretty much it's getting the index of count and adding a new trigger entity. And pretty much whichever was the trigger volume is volume entity, and whatever was the physics velocity, the physics body one, is overlapping entity. So then after that, it's getting this. So it's getting all the entities it's getting the component array thing. Don't know if it's an array, but some sort of data structure. We're just saying array because, yeah, we're just calling it array. So it's getting the array of all entities with overlapping trigger volume. So I'm guessing this overlapping trigger volume component is added at some point at one of these add job handles. Yeah, so in the add new overlapping job, the overlapping trigger volume is added. Well, let's go back to update overlapping job handle. So this is a normal I job. So the previous one was a triggers job, which is when a trigger is called. So the first I job was a for each, which runs on update. Every update with a trigger volume. Every entity that has a trigger volume, it'll do ++ frames, add 1 frame. I trigger events, when there's a trigger event, it runs this. Same thing here, when its trigger is done. A trigger event happens, it runs this. Now iJob, I'm not too familiar with. I don't know what this is. It does something. Pretty much the previous job fills the trigger entities array. So it fills up this array, and then we put this triggers entity into the overlapping group. We put the trigger entities array into the update overlapping job, and in the update overlapping job, we access them in some way. So we're reusing this index. So the index will say how many entities was added into the array. That's why instead of doing the length of trigger entities, it's going to do the trigger entities count, which is actually the trigger entities index. So entities equals the index of the trigger entities. Pretty much whatever index this is, it's getting the trigger index. I don't know how to explain it properly. So for the first iteration of this for loop, it's going to be 0, and it's going to be accessing the 0 of the trigger entities also. Apparently there's some things that they have to do still. It's saying here the volume entity, which was which one was that? It's the trigger volume entity, not the overlapping entity, which is the entity that interacts with it but isn't a trigger entity. Pretty much it's saying if there might be a case where, well, it says it here, the overlapping entity may have jumped from inside one trigger volume into another in a single frame. So that can cause some glitches, I guess. It's not checking if it's the same trigger. I don't know what I'm talking about. Anyways, moving on, it's just a safety check. So from the overlapping group, which was created somewhere, so pretty much all the ones that have overlapping trigger volume, which is added in a different job. Right, never mind. Yeah, actually that's true. It's from a different job. I don't know, my mind's kind of muddled up. There's a lot of text, and I'm parsing it in my mind and trying to explain it. If overlapping group exists, so if the entity from this array, so let's say 0, if it has a overlapping trigger volume, then this will activate. So it gets that component. So let's look at that component again. So it's advancing the current frame. So it's putting the value of overlapping group of the component of so it's getting the index of the trigger entities. So this, the index, which is 0, the first iteration will be 0, this will be 0, and this, if it has the overlapping trigger, will be 0. Is that correct? No, it'll find whatever index this entity is on. And then from that index, we get the component, and we add one frame, and then we put it back into the array. So it's not directly referencing it, it's making a new variable, adding it, then putting it back in. So it's like taking from a book from a bookshelf, writing it down. It's more like you clone the book from a bookshelf, write it down, you destroy the previous book and put in the new book with the new data. That's how it's like, I guess. Here is where we use the entity command buffer. Now, I was confused at what the heck this entity command buffer was, but if you look at the entity debugger, you can see where it's called. So I'm pretty sure it's somewhere here. So pretty much it's getting this system right here. So this system happens after everything is done. Everything in the system, every single system is done. There's probably a good reason to do that. I'm just trying to think of a good reason why. It's because you can't access a static class multiple times in multiple threads. I think that's what it is. So pretty much anything that's done in the entity command buffer system will be done. It will be saved and will be done after all the systems are done. And that's when you want to add components. That's what I've observed. Pretty much you want to use it when you're adding a component to an entity to prevent any issues. So we were just looking at the update overlapping job. Now we're looking at the add new overlapping job. And here we could see it's adding a new command buffer, apparently. Create command buffer. Now I didn't even know what a buffer was until recently. It's pretty much like commands you want to do later. Yeah. It's kind of like with the video. You're saving video frames and you're going to play it later. Now I've never seen this add job handle for producer before. Oh wait, this is for the entity command buffer system. Alright, so let's look what happens here in the job. So it's getting all the trigger entities that we got from, which one was it? From list trigger event entities job handle. That's where we got all the trigger entities. And the trigger count was from the M trigger entities index, which was updated here. It was updated here. It was updated many times, but the last time it was updated was here. Update overlapping job handle. No, it was just red here. It was changed in list trigger entities job handle. So this is just a normal iJob. So yeah, it's getting all the trigger entities, the count of all the trigger entities, the trigger group, and the overlapping group. So these entity queries are actually being used. I'm guessing they're updated every frame. The queries are updated every frame. But since it adds components, it has to dynamically change. So that's good to know, that queries automatically update. Well, I assume it automatically updates. So pretty much it's getting all the entities that have the trigger, the overlapping trigger volume and trigger volume. That's slightly annoying that it's not in order. Small thing. You should keep it in order so it's consistent. Minor thing. There's no issues with that. It's just visually easier to look at, I guess, to follow. So for all the trigger volumes entities, if they don't have a overlapping trigger volume, it'll create an overlapping trigger volume component to the entity using this command buffer with these values. And depending on the type, it'll add different tag components. So these are like tag components. And then the last one is removing components, I'm pretty sure. Remove old job handle. So it's getting the command buffer again, getting all the overlapped entities. Remove the overlapping trigger volume component from any entity that did not have its frame count incremented. So pretty much the reason why we have these created frame and current frame is to check if the volume frame and the overlapping frame are the same frame. And then if they aren't the same frame, it'll remove it. Then after that, it'll make a new job handle. Well, not a new one. I'll use this job handle and combine dependence. I still don't know what this dependencies stuff is for. I just shoved it in and it works. Apparently you need to combine it for these two. So maybe these two happen at the same time. Because I think the first parameter is what it waits to finish. Then it does this. So these two would be at the same time. So it gets the count and gets the trigger entities at the same time, I guess. They're probably not at the same time. Oh no, wait. It does this first, and then after this is completed, because of this, it does this next. And once list trigger events, this job handle finishes, this will execute. And after this one finishes, these two will execute at the same time. So all this to do on trigger and change stuff. I guess the main part that I don't understand is the count thing. I know why it's used, but I don't understand how it's used properly. But yeah, there's the trigger script, which all of these examples share. All three of these examples share that one script. So this example just goes straight down and it just changes the material. And the systems behind that, it isn't even a job, it's just on update. I don't get this using var. What? So this system before was just handling the triggers and adding collisions. Not the collisions, components. Adding and removing components. This system just changes the color. So this one will be running in the main thread because it's not using jobs. And it's getting the component data of the volume. So that's these cubes, and the overlapping render mesh will be from the spheres. And it just sets the spheres material to the volume render material. And this post update command is pretty much, I think it's the same as the command end simulation command buffer. And it sets the render mesh of the entity to overlapping render mesh. Oh, that was a lot to go through. And that's how the materials change. Simple, isn't it? Simple. No, it's, I don't know, pretty complicated. But I'll eventually understand it. Anyway, the next one is portals. And we don't have to go through that code again because it's all the same code. Now we know these portals are triggers. And these static cubes are just the floor to collide with. So they have two scripts. The trigger volume, like before, you could change the type. And the portal behavior, Doesn't look too bad. So it gets all the overlapping trigger volumes and portal overlapping trigger volumes. Change that to array, gets trigger components, portal components, overlapping trigger components, and it's getting the transform, rotation, and physics velocity components. It's adding all this data to this system. I might actually use portals, so this will be useful. So there was a has just entered, which I didn't know what it was. So pretty much if the current frame and the created frame are not equal, that means it exited the trigger volume. But if it's still in, it'll be the same. So it finds the companion entity. So the companion of this black portal is portal 2. Wait, what? Why is it orange and blue? What? Orange, position blue. Ah, I'm pretty sure this is like a portal reference. The portal game reference. Orange position, blue position. Alright, actually I'm going to take a break because I can't really process all this. After processing all of this volume behavior, I might take a short break. An actual short break this time. Eat some chocolate. Watch a YouTube video. Then come back. Because that was a very long script to pass in my brain. So I'll be right back.